Welcome back, everybody. It's Monday, the 28th. We are going to be talking about rotations. On Friday, we learned about translations. We may have talked about rotations a little bit, but either way, here is a video explaining how rotations work in the coordinate plane. So a rotation is a function that moves every point of your pre-image or your starting shape through a specified angle and direction about a fixed point. So they'll tell us what angle they want us to spin it, and they'll tell us which direction we need to go. Again, our two directions are here, clockwise and counterclockwise, but we'll get to that. At any rate, we rotate around a fixed point. The point that we choose to rotate or turn around is called our center of rotation. Under rotation, each point and its image are the same distance from the center of rotation. In this lesson, you can assume that the origin is the center of rotation. So if they don't tell you, hey, rotate around this point, we are going to assume that the point 0, 0, the origin, is the center of rotation. Whenever we rotate a certain angle, again, we have a specified angle that we spin, we call that the angle of rotation. So a lot of these terms just kind of are exactly what they sound like. All right. Furthermore, we can assume, again, that the origin is the center of rotation. The direction of rotation can be either clockwise or counterclockwise. In this course, so this is important in case this pops up, in our course, you can assume that all rotations are counterclockwise. So we will assume that the origin is our point of rotation, or our center of rotation, and we will assume that we are going counterclockwise unless the problem says that we're going clockwise. So if it says nothing at all, we default to counterclockwise, or rotating leftwards. All right, so let's see how it actually works. When a point is rotated 90, 180, or 270 degrees counterclockwise about the origin, you can use the following rules. A rotation of 360 degrees will map the image onto the pre-image. What that means, there are 360 degrees in one full circle. If you take something and you spin it one full circle, it should be back to where it started. So that's what that means. All right. So first, let's look at a 90-degree rotation counterclockwise. To rotate a point 90 degrees counterclockwise about the origin, multiply the y-coordinate by -1, and then interchange the x and y coordinates. So we started off with x and y. First, when I make my new point, I'm going to multiply my y value by -1. So instead of y, it'll become -y. The second thing it says to do is to interchange or transpose x and y. So instead of x, y, my new coordinate, I'll graph it as x, y, but as far as the numbers are concerned, it will look like y, x when we're done. So there are two steps to rotating by 90 degrees counterclockwise. First, you multiply the y-coordinate by a negative, and then we switch the two. I like to think of this as counterclockwise is going to the left, and notice that the new left coordinate, which has switched, is the one that has the negative in it. Okay, if that helps you, keep that in mind, but if not, don't worry about it too much, just remember the rules are right here. It's worth writing this down so that you don't forget. On a test, this would be great to have in your notes. So again, xy becomes -y, x. Here's an example. We have the point 1, 2. If we rotate it 90 degrees, it becomes -2, 1. Again, the x and y flip, and then the y coordinate from the original becomes negative, or the left coordinate in the new one. For a 180-degree rotation, this is actually the same both clockwise and counterclockwise. For this one, for 180 degrees, you multiply both the x and y coordinate by -1. So this one's pretty simple. If you start off with xy, your ending coordinate is -x, -y. So your points are just opposite. So if we look at 1, 2, it becomes -1, -2, which we'll see in this picture. Let's travel 180 degrees or half of a circle, and we end up on the opposite side at -1, -2. To rotate 270 degrees, kind of backwards from rotating 90 degrees. We are still going to interchange x and y coordinates, but instead of multiplying the y coordinate by -1, we multiply the x coordinate by -1. So again, I'm going to do this a little bit backwards. Instead of multiplying first and then switching the coordinates, I'm going to switch my coordinates first. Instead of x, y, I'm going to have y, x. And it said that my x is the value that should have the negative. The reason I did it this way is just so that I can kind of use that strategy that I told you earlier. Actually, no. That doesn't make sense for what I'm saying. But it still comes out fine. We'll do it the way that they intend. Sorry about this. We're going to multiply our x value by -1, -1x. And then instead of x, y, we switch it to y, x. What I was going to say is that rotating 270 degrees leftwards, 1, 2, 3, 270 degrees leftward is the same as going 90 degrees to the right, or clockwise. But if we think of this as a 90-degree counter, or 90 degrees clockwise, we can see that we went to the right 90 degrees, and using that hint I said earlier, the right coordinate is the -1. Again, if that didn't make sense, don't worry too much about it. Just follow the rules that they have listed out for you. At any rate, let's see what rotating 270 degrees looks like. Sorry about that. Here we go. So 270 degrees is 3 increments of 90. So we travel 3 sets of 90 degrees, and we end up at 2, -1, which is interchanged of 1, 2. And our original x value of 1 is what becomes negative in our new point, and it ends up being the y value in our new point. Good morning. All right, so this is how we're going to do rotations. Make sure that you get your DOL done before the end of the day, and you can see me during office hours during 8th period if you have any questions.